Hi, my name is Daryl Miller. I work on the Azure API Management team as a developer. This talk is Agile App Development with Azure API Management. And when I say agile, I'm talking about being able to embrace incremental change with your APIs. And we're going to talk about how you use Azure API Management to manage those change in HTTP APIs. But before we do, let's talk a little bit bigger picture about APIs and the API economy. The API economy is a term that just really talks about the API becoming a first class business concept. It's not just an implementation detail that only developers care about. It's a contract between providers and consumers. Now, whether your API is just a supporting function driving a mobile app or a third party integration, or maybe the API itself is actually a product itself, it's a critical part of the business service. So, how can Azure API Management help you build these types of products? We like to categorize the functionality into these four main categories. We Because we are a layer that sits in between the provider and the consumer, we abstract away the backend and allow you to decouple the interface that your consumer consumes and the backend implementation. This allows you to do optimizations and evolve your implementation over time. It also allows you to repackage your APIs that you expose to your consumers in a different way than maybe it is organized from an implementation perspective. We also, as an intermediary layer, can secure those backends in a consistent way. We can manage JOT tokens and extract claims. We have subscription keys that allow us to rate limit that traffic to prevent excessive usage of those APIs. And we also have, because of the economies of scale, we can cache requests that maybe came in from other users and serve them directly without even putting load on the back end. We can also transform those requests for many different purposes. As an intermediary layer that traffic flows through, we get to monitor all of that traffic. We can observe, we can take statistics and do analytics on that data and provide you with reports so that you have a better understanding of how the API is being used. And you can use that data to monetize those backend services if you want to build an API as a product. And last but not least, we have the ability to help you onboard developers so they can discover what services you provide, learn how to use them, interact with the API, and have all the infrastructure in order to help them join your product offering. So now you have an idea of what the service can do. Let's look at the architecture of how the product is composed. So there are three main components to the product. There's the developer portal, the gateway, and the administration portal. The developer portal is this mechanism that app developers can come up to, they can self-serve and find out how to use your app, and they can manage the production of their application that they want to use to consume your application. The gateway is where the traffic flows through that allows us to do the monitoring and analysis and transformation. And the admin portal sits in the Azure portal and allows you to control how all of that traffic is routed. And on the back end, you have the option. You can host those backends anywhere. They may be in Azure, they may be elsewhere. And they can be developed on any platform as long as it's an HTTP API. So the challenge with change is that HTTP APIs deal with change differently than what most developers are used to, because we're used to dealing with libraries that we add references to, and NuGet packages that we pull down. And the problem with runtime and language is the way breaking changes are defined is it's the compilers and the runtimes that define what is and isn't a breaking change. Whereas with an HTTP API, it is consumer code that defines what is a breaking change. If you have you add a new field to a payload that is returned. You may have one consuming client that's quite happy. It doesn't care that you've added an extra field, but another client coded differently may be upset about the fact that you've made that change. So defining breaking changes becomes very difficult. In a language and runtime API, if you are producing a new version of that library, consumers have to explicitly go and get it and integrate it into their product. They choose when to update on your new version. Whereas with HTTP APIs, the provider actually decides if the consumer can choose. With an HTTP API, you can change the underlying behavior, and that can get reflected immediately in clients that are already consuming that service. Whereas if you want to give the consumer the option to choose, you can create a new resource with a different identifier and communicate with the clients, okay, when you are ready to take on this new change, different behavior, then you can opt in to calling this different API or this different resource on an API. So in order to make this distinction clear, we'd like to introduce some new language here to make it easier. Now, the terms versions and revisions are often used interchangeably within software development. However, I'd like to propose that we use versions to say when consumers are choosing when to adopt some changes, whereas revisions are changes where the providers choose when to deploy. Now, this is an alternative to the semantic versioning model where you have major, minor, and patch, because that model is based on understanding what it means to be a breaking change. And as we've seen, that's not so easy to do in an HTTP API. Now, the question is, I made a change to my API. Should I deploy this as a revision or as a version? Well, that depends. You need to communicate with your consumer, and you need almost like a change level agreement, something where you say to your consumers, this type of change, I'm just going to push as a revision, and you need to build clients that can consume this kind of change. But this other type of change, which is potentially more significant, I guarantee that I will introduce a new version in order to be able to bring this so you can choose when to adopt this change. And with this kind of establishing this kind of change level agreement, you have the opportunity to build clients that are a lot more resilient to changes that are happening within APIs. So the question is, how does API management help you achieve this? How does it help us deal with these versions versus revisions? So we've talked a little bit about the developer portal, and the developer portal is the place where we can advertise change to our consumers. We can say these are the APIs that are available, and here's a new version of the API. We have this notion of the API contract, and that is basically our interface, our HTTP interface. It describes if we are making a change, the API contract will describe what is changing. And changes in contract, they may be versions or they may be revisions. It depends on this change level agreement. Now, the gateway, which is our intermediary component, that can act as a facade to the API implementation, and it allows you to isolate the backend. And that's where you can hide the revisions. So let's look a little bit more into these three aspects, and then we'll see actually how the product enables these capabilities. So the developer portal, and this is about facilitating onboarding of developers. And the API community has recognized that this is a critical thing for adoption. Talking about change is somewhat irrelevant if nobody is using your API. You want something that's easy for developers to come to, sign on, support multiple different identity providers. You want them to be able to discover the services that you provide, try them out without actually building any code. And then when they do come around to actually building code, help them build client SDKs that will allow them to consume your API easily. When the consumer of your API starts to build an application, actually starts to distribute it to their users, they then want to be able to monitor that API and see how it is used and get reports and analytics on how the API is being used by their application. They want to see what they can improve because knowing what to change is as important as how it can change. Which brings us to the API contract. So this has become very popular over a number of years of way of describing an HTTP interface, and we support a number of different API description languages, going all the way back to WSDL support for people who want to facade over legacy SOAP APIs or want to just track analytics of APIs of SOAP APIs. Unfortunately, WSDL got kind of complicated and got a bad reputation because it tried really hard to support all different kinds of protocols and abstract away the interface, whereas Waddle and OpenAPI really just try and describe HTTP APIs. Waddle's fallen out of favor a little bit because it uses angle brackets instead of curly brackets, and the most common spec these days is the OpenAPI specification. You may be more familiar with the term Swagger, although it has recently been renamed. Microsoft use OpenAPI spec throughout a number of their products in order to enable integrations. And the third aspect of managing change is about being able to handle hiding back-end implementations. So there are a number of different ways, even on Azure, where you can implement HTTP APIs in different ways. And some of these services fit better for different scenarios. And how a feature needs to change might be a determining factor on which is the best service to use. And we're going to see that in the demo that's coming up right now. So you can now see a dashboard that I've created for various services that I'm using within this demo. And I'm going to click on the API management service. If you've used API management in the past, you may be familiar that we used to have a lot of management functionality in a separate publisher portal. That's still around, but almost all of the functionality has now been migrated over into the Azure portal, although it is still tagged with the preview capability. The developer portal is still external and can be accessed from here. I'm just going to click over onto the developer portal that's already open here. So this is a bare box out of the bones developer portal as it comes, but this is completely customizable. We can click over here on styles. Because I'm an administrator, I get this little side menu where I can change the styles, and I can go in and I can change individual templates for various parts of the application for the list of APIs and the list of products that are supported. We can also completely add new pages to the portal. This release notes page, which I added, is a custom page that I added. You can add any HTML, point to any other external reference here, and integrate it into a seamless experience. If I click on the list of APIs, you can see APIs that are advertised. I have a version 2 API and also version 3 that I'm working on that's supposed to be accessing an ASP.NET Core implementation. Now, you will only see the APIs as a developer that you have been given access to. APIs can be grouped into products. So you could have kind of a beta channel of products so that only certain developers would see certain APIs. And I'm going to drill down into this particular conference API. So this is an API for managing a conference. It has sessions and speakers. The names of the operations are a little ugly because they were actually imported using an open API specification. You don't have to configure all of this manually. You can import in. And actually, this open API specification was generated using Swashbuckle. If I dig into this list of speakers here, I can see the documentation for this particular operation, what headers. I can see sample responses, and I can even get little samples of code in various languages that show me how to actually access this API. It's all about making it really easy for the developer to be able to consume your API. And I don't even actually have to write any code. I can go straight to the try it button, and I can all of the parameters are filled in, including subscription key, and I can make this request and send it off, and I get a response. And it needs to be warmed up a little bit. There we go. Back the response back in 47 milliseconds. And we can see the results of the response here. And I even get tracing information to show me timing information. As this request passed through the gateway, I get timing information about how long it took to do CORS handling and rate limiting and all the other features, so I can ensure that I maintain optimum performance of this API. Now, I mentioned before about the fact that once we've got our API running, a consumer of that API who's building an app wants to know how much that API is being used and what is being used for. If you go over to the profile of the user who's logged in, you will get statistics based on subscriptions as to how it's being used. So we get keys here for the subscriptions that are used to access these APIs. And we have a primary and secondary, so you allow rollover of keys in case a key is compromised. But if I click on the analytics tab here, this gives the developers of the consumers of an API a graphical view and statistical view of how that API is being used, which products are using it most often, which operations maybe are failing more often, all the regular statistics that you need in order to be able to make decisions about how to improve a particular API. So I'm going to return back over to the Azure portal. And looking at this API management service here, you can see there's the URL that we use to access the developer portal. And there's another URL that allows us to access send the request to the gateway, which will then be forwarded on to your backend API. Now, these names can be customized with your own custom domain name. And over on the left-hand side, you can see the various elements of the management service. If we click on the list of APIs, we're going to see the same set of APIs that we were able to see through the developer portal. However, from here, we can actually manage and manipulate those APIs. And there we go. From here, we can also add new APIs. And as I mentioned, you can import from Open API specification, Waddle and Wizdle. You can also easily connect up to existing services that you've built, such as Logic apps and API apps, and coming soon, function apps. And this is all enabled because all of these services expose their interface using an Open API or Swagger description. Going back to our conference API, if we click on an individual operation here, this is getting a session by an ID. You can see this front end box is a description of the interface of how you call this particular operation, along with parameters. I can edit this by clicking on the pencil icon there, and I get a form-based dialog that allows me to edit all of this information. But I also have another way that I can edit this. I can edit this directly in a text-based specification using a YAML representation of the Open API specification, which is edited directly in line. And it really doesn't matter whichever you prefer. You can edit it via the form-based approach, or you can edit it via the text-based approach. So this is how the contract is accessible and visible and usable via API management. And let me just close that back out. So that was the sessions API. Sorry, the get by session ID. But perhaps I don't want to necessarily access the backend API because I need some additional services that maybe it's difficult for me to implement. Here we have a forecast operation. And in this forecast operation, what we want to do is on the home page of our conference website, we want to display what the weather forecast is for the day of the conference at the particular location. And we don't have that information. So we were able to use policies. If I click on the inbound processing, so the request comes in and then we manipulate and change that request so that we actually call we're calling the dark sky API here, and we know the location of the conference and when the conference is going to occur. So we're able to change these inbound values and redirect to a backend API. And now from this particular operation directly within the portal, I'm able to test this. So I can send this request off through the gateway, applying all of our standard rate limiting and security policies, but then call the backend API to get the weather wherever the conference is located. So this is a demonstration of how you can access backend APIs, but still provide a consistent front-end experience to your consumers. Now, again, this is a conference API, so we had another idea of when people are submitting proposals for the conference, they submit a session, you look at the thing and say, okay, well, can this person actually speak? Are they any good? Would be nice if we could see existing examples of this particular speaker's talking background. So we created this API called Speaker Research, which allows you to put a name and a keyword, and it will go off and find videos that this speaker has already done. But the team's working on the V3 of the API, and I want to hire a contractor to be able to do this particular work. So I don't want them accessing the main code base of the V3 API. So I'd like to be able to independently develop this. So what we did is we actually connected this particular operation up to an Azure function backend. If I go over to this window I have open over here, which is an Azure function that goes off and uses the Cognitive Services API of their video search and takes the name and the keywords and makes the request and returns back a subset of that because the Cognitive Services brings back all kinds of information, reformats the response and returns it back to the API management or to this conference API interface. And if we test that, I have to actually provide information. Let's see whether I've ever done this before. Hypermedia is something I like to talk about. And I'm going to send this request off, and it hits Cognitive Services, which hopefully is running extremely quick because they also use API management as their front end. And there we go. I did a talk about Hypermedia, Xamarin Evolve, and I have several other talks at RESTfest. So this is a way to quickly access information from a third-party service and have it developed independently and separately to the main work that's going on in the API, but still provide a consistent external experience. Which brings me to my last example, which is this submitting proposals. So in the case of submitting proposals, we want people to be able to submit their session proposals and enter information and provide us with what they would like to talk about. And that usually goes to some kind of committee that reviews it. But different conferences have this review process in different ways. And if we want this API to be used by lots of different conferences, then we need the flexibility of having almost like a workflow mechanism to allow this review process to occur. Well, reinventing a workflow process doesn't make a whole lot of sense, especially when there is one already available, which brings me to the use of logic apps. I designed a logic app, and it is the world's simplest logic app where we bring in a request and we send an email. But you can imagine having a bunch of conditional work here that looks at the requests, looks at the input, the sent submission, and analyzes keywords and decides who may be the best person to review it, and then accepts feedback from the reviewers in order to decide whether it should be approved or not. And conferences could configure this on a case-by-case basis. So in this particular case, if I go back to my API and actually test this one, oh, I already am in test, and I say this, I need focus. This is a awesome submission, and I send that off, and it's going to return a 202 accepted because it's going to go off and do some other work. And we probably want to go through and add some policies to strip off all of these headers because our consumer doesn't need to know that we're using logic apps behind the scene. And if I can bring my mail client up here for a moment, hopefully, there we go. This is my previous test. No, it's not. This is an awesome submission. There you go. This is the one that I just received from Logic Apps. You would have seen it in the pop-up if I was sharing the other window. So this is an example of being able to develop a feature which has a different life cycle than the rest of the product, because this workflow is going to potentially change on a conference by conference basis, whereas the rest of the API is the same for all the different conferences. And this can be presented in a consistent interface to the consumer of the API. Now, what I would love to be able to do right now is to be able to show you how API management manages revisions and changes directly within the Azure portal. However, unfortunately, time and technology were not on our side, and we will be releasing a private preview of the capabilities to be able to do revisions and versions directly within API management at build. But it was not in the position for me to show you today. So what I am going to talk about is how we expose in the API those different capabilities. So a URL where you access a API that is hosted by API management is kind of broken down into different pieces. It has the service instance, which can be your custom domain as the first portion, and then a prefix on the path is the name of the API. And then we can have version segment to identify version 2 of the API, version 3, so that the consumer can explicitly choose when they want to change their client application to consume version 3. The next segment, the revision segment, is kind of hidden. This is not necessary to include because if you'll notice, these revision 3 of the V2 and revision 1 of V3 are marked as current, which means if you do not include this matrix parameter, then it will assume you mean version 3 of V2 and revision 3 of version 2 and revision 1 of version 3. So this is an optional segment that consumers of the API really don't need to use unless they want to potentially participate in a beta program that allows them to test a revision 4, or your own developers working on your own on the API, they can add in this matrix parameter in order to be able to target specific revisions of the API. And when you have decided that, yes, revision 4 is ready to go, we've tested it sufficiently, you can just set that revision 4 to be current, and it will become the new default when somebody does not specify a revision. The revision 1 here is gray because it was taken offline and made not accessible. We're not going to allow anybody to take a look at that moving forward. So this additional optional parameter that exists in the path allows you to control which particular revision that you are working against. Now, I've included versions in the path, but that isn't absolutely necessary. There are different people have different perspectives on how they want to do versioning, and you can have the version in the path, or you can put the version in the query string. You can also, if you really choose to, put the version in the header. And some people like versioning their media types, and Azure API Management already supports that because we support having different representations for a particular operation, and standard content negotiation will take care of that. So that brings me to the summary of how we are managing change with API management. We have the developer portal for advertising change, for letting people know that there are new versions of an API that they can use. We have access directly to the open API contract of the API to describe that interface and to be able to manage the changes that are happening to that contract. Versions and revisions allow you to control when your consumers will see those changes, whether they can opt into them or whether they get them automatically. And the gateway transformation policies allow you to hide implementation details that you don't want to leak out and allow you to make changes behind the scenes without actually affecting your customers. The Azure API Management Service, we have close to 8,000 customers now, many of them Fortune 100 customers, or 21% of Fortune 100 customers are using us. We get close to 20 billion calls per month, and our largest customer is hitting us with 250 million calls a day. So we are a proven and tested solution available in 27 different regions, and we are constantly working on bringing new features. And if you want to take a look at our product roadmap, we have a Trello board at aka.ms APIM roadmap that shows what we're working on, what we've completed, what is next up. And you can go in there and you can vote on what you think we should do and add comments to tell us how you feel about the product. And with that, I thank you very much for taking the time, and I wish you'd go give API management a try and help it manage your APIs.